All right, welcome to 2018, the year that the world figured out that the earth is flat. I think 2017 was a pretty good year as far as expansion of the flat earth knowledge. There was a lot of new people came out making content about flat earth. There was the first conference. A lot of people were having flat earth meetups and all that. But if you're new to the concept, you're probably going to get a whole lot of the same responses that people give you on a regular basis. You're excited about the concept. You don't quite know what to say. And some people will come to me saying this. You know, it's really simple the way that I explain it. Look, bottom line, the Earth's surface is mostly water. You don't have to say any percentage, but bodies of water don't curve. Period. You pour a glass of water, surface is flat. You look at a puddle on the side of the road after it rains, the surface is flat. You ever been to a swimming pool? Before anybody jumps in from one end to the other end, it's flat. You go out to the lake, you've been fishing, you've been out on a boat, whatever, it's flat, right across. The ocean plays by the exact same rules. And then when people say, well, what about when I see boats going over the curvature? Well, the fact of the matter is, if you take out a telescope, a pair of binoculars, or a camera with a good zoom, you take that boat that you thought you saw go over the curvature of the water and all that, and you can pull it right back into view. This has been done multiple times. That's not even an argument. It's all about perspective. That's what made you think that you saw a boat go over curvature. The fact of the matter is, everywhere you look, everything that you look at, the further away something gets from you, the smaller it becomes. I know you know that. But the thing is, and you probably learned this in art class, you might have forgot about it. Okay, you had to draw that city street. And in that city street, you saw everything shrinking into the vanishing point. Just the same. You can see it right behind me right now. You know that this van, these little wooden panels right here, this is all about, let's say about 1.5 feet apart. But you see how it seems to go inward towards the back right there. That's the law of perspective. Everything goes into the vanishing point. That's why you think that you see things going over curvature. Some people are going to say something like, oh, the earth is flat. Well, why don't you show me the edge? Why don't you show me the edge of space? How about that? All these satellites are supposed to be out there beaming back these crystal clear high-def pictures of all these stars and quasars and planets and all that mess from millions of miles away, but you can't go from one city to the next without dropping your call. But these satellites are supposed to be sending all these images from millions and millions of miles away. But go outside some night, and we're supposed to have thousands and thousands of satellites up there orbiting between the Earth and the moon. Go look at the moon for maybe an hour or so, however long you want, and I guarantee you won't see a satellite going in front of the moon. Between you and the moon's supposed to be 238,000 miles away. You're not going to see a satellite going between you and the moon. Go stare at it. Go try it on a clear night. Go ahead. You know, people like to say, well, what about the southern stars? You know, the southernmost parts of some continents, they all see the same stars rotating. Yeah, they see the same stars rotating. You're saying it yourself. We shouldn't be seeing the same constellations every night. Okay, you've been seeing the Big Dipper since you were a child. Why do we have a North Star? I mean, seriously, we have one star that's been in the same place for all of your life. Throughout all of recorded history, these people used to navigate from one continent to another based off of that one star, and it's never moved. But the Earth is supposed to be orbiting around the sun's supposed to be orbiting around this. The whole galaxy is supposed to be going this way. And come on, man, all these things are supposed to be taking place out in space, all this movement, and yet we still see the same stars. I mean, seriously. Well, I mean, you know, they'll say that the stars are moving with us. We're not moving. That's the thing. Go outside. You understand your five senses. If you're standing on top of a car and that car happens to be going down the road at 15 miles an hour or something, you're probably going to feel it if it's moving. But we're not. And this is when people are going to say, well, the atmosphere. Okay, fine. Question for you. Other than the Earth, can you give me an example of an enclosed system existing next to a vacuum without a physical barrier? Nobody ever gives an answer for that, other than, well, what about Venus? What about Neptune? You've never been there. You've only been on Earth, and you're just saying words, giving these programmed responses. But okay, let's go with that. Let's say that we don't feel any movement on the Earth. We can't feel any of this rotation. There's none of this chaos that will be going on the Earth that's moving because of the atmosphere. Okay, fine. How about when the guys supposedly went to the moon and they're out there on dune buggies playing golf and all that, but the moon has no atmosphere, right? Moon's out in space, no atmosphere. The moon's supposed to be traveling, orbiting around the Earth, 2,288 miles per hour. Somewhere's about.
Now, just for a basis of comparison, this is a guy trying to stay upright in 109 mile per hour winds. This guy, look, he's going to fall. Up, there he is. Falls, hits the ground. Can't even stay upright. Struggling to make a few steps. 109 mile per hour right there. Now, where are these 2,288 mile per hour winds? Because, I mean, there's no atmosphere on the moon, right? They should be experiencing some sort of wind hitting them, whipping them all around. But everything looks like it's nice and cool. You see the flag hanging there. You know, you're going to see a little string. Oh, wait, can you see the string reflecting off the guy's backpack? Yeah, there it is. Okay, yeah. So nice and fake. Those guys didn't go to the moon. This is all bogus. Anyway, let's get back to the video.
They should have got whipped off of the moon because there's no atmosphere. But everything looked like it was nice and calm out there. No atmosphere, nothing blocking them from the vacuum of space and the surface of the moon. So what is it? Because it seemed like everything was nice and cool on the moon. But no, it was the atmosphere that keeps us from feeling anything here. But they're out on the moon, so there's something different going on. Let me guess. Gravity? People are going to come around and say gravity, okay? That which you perceive to be gravity, the force of gravity, supposedly, things rise and fall based on molecular density, okay? The helium inside a helium balloon, helium on a molecular level is lighter than the oxygen outside the balloon. So that helium causes the balloon to float, okay? Your phone, when you drop your phone, that's because your phone is more dense than the oxygen that surrounds it. That's why it falls. But if you drop that same phone in the water, that same phone, because it's more dense than the water that surrounds it, that phone's still going to sink. But what's going to happen is the bubbles are going to escape that phone because there's going to be oxygen inside that phone, and those bubbles are going to float right back up to the surface because the oxygen is less dense than the water that the phone fell into and that the bubbles are surrounded by. So everything is just trying to find its own balance within the density, okay? That's all that is. That's all that is. There's no imaginary force. You're going to say gravity? Okay, so you're telling me that sometimes gravity's pulling things down to the surface. So if you jump and you come back to the ground, that's because gravity pulled you there. Okay, but there are people supposedly upside down, thousands of miles beneath your feet, living, operating machinery, flying planes, riding bikes, living their lives upside down while there's water sticking to the bottom of a spinning ball. Yet, gravity's strong enough to hold all these trillions of gallons of water to the bottom of a spinning ball, but yet a little butterfly can go flying around with no problem. Okay, so gravity pulls things to the surface, but when it's out in space, gravity's not strong enough to actually pull anything anywhere. Gravity causes things to just orbit. So it's very selective. Sometimes it pulls, sometimes it just causes to orbit. We can't really figure out what gravity is supposed to be doing here. That's because it's made up, okay? Gravity's their little go-to to make sure that they can explain everything that makes absolutely no sense in this silly, ridiculous heliocentric model. What I'd like to ask somebody is, well, gee, I don't know. Here, can you make water stick to a spinning ball practically? Seriously, can you do it? Nobody really can. Here, hold on. Here, what? Here's a globe. You know what's gonna happen if I take this little Lego guy and I try to stick him to this side? I think you know exactly what's gonna happen. You know, if I try to stick him, make him stand up here in Africa, you know what's gonna happen? I think he's gonna fall off, right? Try to make him stick in South America, he's gonna fall off. America, he's gonna fall off. Oh, because it's tilted, right? Okay, yeah, but it's not big enough to create gravity. Yeah, water doesn't stick to a spinning ball. Now, let's try that on a flat earth map. Ta-da! Oh, look. We say that things go up and down. There's an up and there's a down. There's no imaginary force making these things happen. So here, let's try Africa. Oh, look, he can stand in Africa. What about South America? Oh, look at that. Oh, wow. What? Well, North America? Oh, what? That's craziness. Look, gravity's a hoax. Okay? If you believe that crap, I really don't know what to tell you. You're an adult, for crying out loud. It's about time to leave the fairy tales in the past. Okay? Right back there with the Tooth Fairy, right back there with Santa Claus. It's not real. Santa Claus, Tooth Fairy, Easter Bunny, gravity, put them all in the same box. It's all bull, okay? But science, people are going to come out and say something about science. They won't really give an explanation. Guys do this to me all the time, just out of nowhere. Science. Okay, so you'll just sit here and scream science and think that's supposed to give you some sort of practical explanation for things that you can't really explain on your own. Basically saying that you've pretty much abandoned your common sense and gave it away to some dude in a lab jacket. So what you're telling me basically is that some dude in a lab coat can walk into a classroom, pull out a marker, go to a huge board. He can start writing symbols, letters, and numbers on a board, and some way or another, he's going to convince you that Miley Cyrus is built like Jennifer Lopez? Come on, man! Look. This is a simple kind of thing, okay? We know flat, we know curved, all right? The earth is Miley, baby. It's flat, okay? Get up on that, all right? These are facts. It is what it is. You can't see any curvature. There is no detected motion. You know that. 2018 is when common sense is making a comeback. Flat earthers, we call it how we see it. We see flat, it's flat. We see that we're not moving, based on our common sense. Our five senses tell us that we're sitting still, period. You don't feel any motion when you put your feet on the ground when you step out of the bed in the morning, do you? Of course not, because it's not moving. Have you seen any curvature? Do you really think that so after a certain amount of miles of flat water, then it suddenly just starts to bend? Really? You think so? Come on. Welcome to the show. It's 2018. The earth is flat. From here, spread the truth, expose the lies, demand answers. This is the Flat Earth Offensive. You are the resistance.